kind of what I had planned today was to talk a little bit about what we do. Has anybody heard of Fastenal? This, I can kind of see you guys. You can just raise your hands if you or nod your heads. You've heard of Fastenal. Okay. Is there anybody that's willing to speak up and tell me what they think that Fastenal does? No, nobody. Got radio silence. So Fastenal is a company that was started here in Winona, Minnesota. That's where I'm based out of. And started as a distribution business, selling nuts and bolts and other fasteners. So when we got our start, we were basically buying product in bulk and then selling it in smaller quantities. So as a distributor, we basically are the middleman between somebody in the world that's making a part and somebody in the world that needs that part for their project. So we'll buy it from the manufacturer and then we get it to the end use customer. Now, what I do here in Winona at our manufacturing facility is a little bit unique in the industrial distribution world. Fastenal doesn't just distribute parts. We found that there was a market for custom parts or parts that were, a little bit off of standard. And we started modifying parts from the get-go and making them to the customer's requirement. And ultimately, over the years, it has built up to our Fastenal manufacturing that we have today. So what I do is I work in a business unit here in Winona that has CNC machinery, and we are doing custom turning and custom milling and forged parts, hot forged, where we actually take a blank and heat it up and then press it into a die. So the parts we make are not the standard off-the-shelf type parts that you would normally think of at a hardware store or like Menards or Fleet Farm. We're making stuff that already has been sold. Everything we make has a customer waiting for it, and it's designed and engineered for a special purpose. Everything from, we do a lot of oil and gas stuff. We do stuff for the defense industry. We do stuff for, big projects like the U.S. Bank Stadium. I think I read we just got an annual employee report. I think we had parts that were in the Ram Stadium that they put in this last year. And, everything to Disney World, roller coasters to, MRAPs and vehicles on the battlefield. So when you talk about the parts that we make here, a lot of it is safety critical. It's not something that you just go grab a bolt off the shelf and stick it in there. If you're talking about a pin that holds a wheel on a roller coaster, you want that designed and engineered to do just that. So that's a little bit about what we do here at manufacturing. Obviously, Fastenal as a whole is a great big company. We're a $5 billion company, and we end up doing a lot of that is the distribution side of things. But we also have opportunities here in Winona for anything that can make a large company go, such as marketing. We've got truck driving, we've got HR, we've got kind of anything and everything that you could ever dream of. So what I was going to do, talk a little bit about our manufacturing stuff. I've got a short video that kind of, it's not our video. I stole it off the internet, but it's a great video that kind of depicts a lot of the things that we do. And it's put out by Red Bull Racing. So that might get you guys kind of excited, but I'm going to see here if I can figure out how to share my screen. I got to share sound, screen to share. All right. So can you guys see the screen that's in front of me?
Yes.
It says we design, produce, and inspect. Okay. So I'm gonna start that little video. And what I'm thinking we'll do is we'll go through this video. It's pretty short. It's a couple of minutes. We'll go through this video, and then what we'll do is we'll go back through it, and I'll kind of explain what's going on at different steps through this video. And if any of you have questions while we're going through that explanation, that'd be a great time for you guys to pop in and ask some questions. And I don't know if maybe Miss Tishammer, you can kind of field questions if you got some in the classroom. So can you guys still hear me over the top of that video if I mute it now?
Yes.
Okay, I just wanted to make sure like all my sound didn't just go to the video. So what'd you think? Kind of a neat little video? Yes? Shake heads, yes, and yes, no, maybe. Don't want to see it again? So one of the things I wanted to do was kind of walk you through this, because really this is exactly what our shop does. It's more so than just an assembly line. We do a lot of different parts, and we do a lot of custom orders. They're small piece orders to large piece orders. We're considered a job shop. So here in this part of the video, we are drawing the conception of that part, and then we're putting it into a CAD model. So we have a CAD department. The first step in getting an order at Fastenal Manufacturing for our customers is to actually work with our store, and then our store will call our sales folks, and we've got a team of sales folks up in the office, and what they do is they put together the order, and they basically find out the information from the customer of how many parts are they looking for. Is there a certain material they're looking for the part to be made out of? Is there a certain grade or specification? A grade 8 bolt that you would get off of the shelf is obviously going to be a harder, stronger bolt than a grade 2 bolt that comes off the shelf. A grade 2 bolt is kind of considered a soft bolt, but depending on the application, you may want one of those properties or another. And then there's all sorts of other exotic materials that we can make parts out of, such as Inconels and titaniums and stainless steels and things like that. So depending on where that part is and what kind of environment it's going to be in. You might want to select for strength. You might want to select for ductility. You might want to select for corrosion resistance. So there's lots of different options and things to think about there. So that's kind of where it starts. And then it goes to our Cad department. So our Cad department is going to do just what you're seeing here. Is you're going to see them draw a picture of this part. Has anybody done any Cad work with any of their classes in high school? Do you guys have that offered at Caledonia or Rushford or Spring Grove?
I'd say, Willie, the only experience they have so far is Tinker Cad. So that's Tinker Cad. So it's a simplified.
Okay. All right. So
then they design things for the 3D printer.
Yep.
And print it off. So that's the most probably experience, I think, isn't it, you guys, that you probably have?
Cool. So the way I like to look at blueprints, can you guys see me too on the screen in a little picture, or is it just a bolt?
Yeah, you're off to the side right by the bolt.
Okay. You know, one of the things that I like to talk to students about when they think about Cad drawings is really most people have been exposed to Cad drawings at a probably young time in life. I've got a little trinket here on my desk, and because he actually helped me design this part. He's big into Legos, and this is a Fastenal truck made out of Legos. So I want to give credit where credit is due. Tyler's on the call, and he helped us design this. I kind of gave him some directions, and I said, hey, I want it, you know, kind of less than 50 pieces, and I want it to look like a Fastenal truck. And then what we do is we put together a set of instructions. So if you've ever played with Legos before and gotten a set of instructions of how to put that together, essentially what you're looking at is really a blueprint. And all a blueprint is a drawing or a set of standardized instructions that would allow anybody to put the part together. So that's what our machinists will work off of in the shop, is they will work off of that Cad drawing, because as long as you know how to interpret and understand and read those drawings, there's no way that you're gonna you know, make a part. If it conforms to that drawing, that part should be exactly what the customer wants. So that's kind of the first step. So I'm going to hit play here and let this play a little bit more. Obviously they're doing some Cad work and some model work on the screen there. And after that's done, it's going to go out to their production team. And that's what we do. We print it. They're selecting the material here. Our material comes in from all sorts of different vendors, get it to the machinist, and then they're going to set up the machine. So he's writing a program with a CNC machine. This is actually a turning center. So the way that you know the difference between a turning center and a mill is a turning center will rotate the material. So in this part, if we go back just a little bit, you can see there, let me see if I can pause it. You can see there that this chuck is turning and that material is turning, and the tool that comes and cuts it. And I think if we go back even a little bit further, you can see that tool come in there, right there. So this is a tool. It's going to come down and cut it. So the tool is stationary while the material turns. In a mill, it's a little bit different. It's kind of the opposite. The tool is actually rotating, and then the material moves because it's clamped into a movable vise that has an X and a Y axis. You can get more axes on mills, you know, so you can get as technical as you want, up to, you know, 5, 6 axes. Here, he's opening a drawer. He's got a drawer full of gauges, and, you know, there he's making sure that that part is going to conform. So threads are actually one of the most technical things that we do. And it's a little bit tough sometimes to get all of the dimensions and all the components of a thread to work correctly. So the best way to check it would be to use a ring gauge like this. So this is a gauge that would spin on, and usually they're in a set. So usually there's one that will go on and there's one that will not go on. So it's called a no-go or a go gauge. And they come in pairs, and then we'll use stuff like that along with calipers and micrometers and things like that. But our machinists are what does that. The person that's actually creating the program, working from the blueprint, you know, they power up the CNC, they program it, they put in the tooling that's required, they turn the parts out, and then they're inspecting the parts on the backside as well. This is an optical comparator. So this is kind of a neat tool. We've got several of these on the shop where you can actually zoom in and you can see features, and you can actually use this to measure. So this line here and this line here, it looks like they're about 5/1000ths apart. So you can actually line up those lines and measure radiuses and things like that. Now he's doing a hardness test. So we have a A2LA accredited lab here in our shop. It actually is not a part of Fastenal manufacturing, but it is a part of Fastenal, and it's a part of Fastenal's quality division. So the nice thing about that is that they actually give us a little bit of separation from manufacturing to our testing facility, and we can actually use our own lab as a third-party test. So meaning the folks in the lab report to somebody different than manufacturing, and the reason we want a third-party test is so that there's no question that, you know, me or as a machinist, I can't say just make it pass, just write it in. You want somebody in there that's truly a third party, and by having those folks in-house and this testing ability in-house, it saves our customers a lot of lead time. We don't have to ship the parts out to get them tested. This is a liquid penetrant test here. So what he's doing is he's putting a fluorescent liquid on there. He's submersing the part in there. He's looking for any cracks. And once you look at that under a black light, if there were any cracks, that liquid would have seeped into those cracks. And I don't know if this is intended to be a crack right here. Can you see where my arrow is? But those types of things show up. So I don't know if that's just a reflection from the camera or if it's actually a crack, because I see this is actually the dye here in the thread there, and it's a little bit brighter. So it might not be an actual crack, but that's kind of what it would look like under that black light. And you would not, a lot of times you can't see those cracks, those minute cracks with your bare eyes. So he's checking that over, making sure it's good. Obviously, if we're putting this on a race car, holding the suspension together or the front end linkage together, we don't want that part to get broken or to crack or to break. They're doing a laser etch on it. It's just a serialization. They want to put their number on it. We've got those capabilities. We will serialize and stamp and mark our parts if a customer is looking for them. Sometimes we provide full on traceability for most of our parts. We actually do provide that. Depends on how far they want to go. If they actually want that traceability and a serialized number on the part, we can even tell what part of the run that part was run in then. So anyway, that's kind of our machinists at the end of the order, they'll box up those parts and they'll put a sticker on them. They'll put a shipping sticker on them and get them out to our shipping department. So a lot of times from start to finish, it's one person doing that job. So as you can kind of tell, what I was saying is it's not the same type of assembly line job. It's very different from day to day. If you're working on a 5-piece order or a 25-piece order, even sometimes it might take you an hour and a half or 2 hours to set up a CNC machine with a program and putting the tooling in to run that part. But then when it's all up and running, for 25 pieces, maybe that only takes you 45 minutes or an hour. So if you come in on an 8-hour shift, there's a good chance that you might work yourself through 3 or 4 different parts. And, it's not doing the same thing over and over again for each part. You've got to, pick it up and program it and go from there. About 50% of our work is repeat work. So we do save CNC programs so we can save time that way. If we've run it before, we'll be able to pull in a past program and get that up and running. So are there any questions at this point? Kind of been talking for 20 minutes or so. Any questions that you guys have about what you saw in the video or nothing? Okay. So any of you, just by a show of hands or a nod, is there anybody that's interested in a career like this? Does this sound like it's hands-on enough and something that would be kind of cool to explore? Yes, no, maybe? Okay. I can't see the whole class over there, but One of the things that we have, you know, you don't have to go to a 4-year college to get into a program or to get into a career field like this. This is a very in-demand career field, and it's going to be even more in demand, I think, in the upcoming near future, because you know, there's folks that are retiring out of this field. More of our customers here at Fastenal are requiring domestically produced parts, which means they want those parts manufactured in the U.S. with U.S. made goods. So Southeast Minnesota and Western Wisconsin is kind of a mecca for advanced manufacturing, which is a category that this would fall under. At Minnesota State College Southeast here in Winona, we have a program that is, you know, focused on teaching students how to operate CNCs and other machine tools to do just this, to do this machinist work. I pulled up a flyer here, and this is just kind of the top of it, but you know, if you look at the top there, I've got 4 things that are kind of checked off, and a lot of people like these 4 things. You know, 2-year degree. It doesn't require you going to school 4 years and racking up a bunch of debt. 0 student debt, because if you go through my program here at Fastenal, I'm going to pay you back for your tuition and books. As soon as you complete the degree, we start paying you back your tuition and books. You know, it's a rewarding hands-on career. How many of you guys like shop class? Yeah, I got some hands there. So shop class is one of those classes that you like because it's hands-on, right? You get to take something home at the end of a project. You design something, and then you get to physically make it, and you get to hold it in your hand. And we do that all the time. And then, you know, high skill, high wage. It is a high skill job. This is not a job that you're going to come in and skate through and not learn. So you're going to use your brain. A lot of people like the challenge. It isn't something that you can just come in and push a green button all day. That's not what we're looking for. We're looking for those folks that like the challenge of, you know, of using their brain on a day-to-day basis. Math skills are important. You know, it's not tough math. It's not calculus, but we do get into some trigonometry and some geometry, because essentially what we're doing is we are telling those machines, those CNC machines, what the part looks like with numbers. And we pull those numbers off of that blueprint. Sometimes the number we need is not listed on the blueprint. So we might have to do some calculations to figure out what that missing number is so that we can plug it into the CNC. What we're looking for, this is kind of a flyer that kind of goes over our sponsorship program. Really what we're looking for is somebody who wants to go to school for that tool and die degree. We'll bring them in here and we'll get them working part-time. A lot of times I like to do that right after, you know, right after high school graduation. So we'll bring them in and get them working here throughout the summer. And then they start school that fall in August. They spend 2 years working for us part-time and going to school. Upon graduation, we guarantee them a full-time job, and we start paying back their tuition and books. And that works by getting a payment for a quarter of it every 6 months until it's paid for. So it takes 2 years post-graduation to have it 100% paid for, but by then you've got a 4-year track record with a global company like Fastenal, and hopefully you're well on your way to those high-wage, high-skill jobs, you know, right with us, and hopefully you want to stick around. There are opportunities to move and do other things with this company. We're a global company. I believe we're in about 28 countries. Our manufacturing side of things is in the U.S. We've got 6 facilities, and we've also got 3 facilities overseas, one in Malaysia, one in the Czech Republic, and one in the U.K. So there is opportunity for people to advance and move up. And really what I tell people is the only thing that's going to hold somebody back or, you know, put a glass ceiling over their head is themselves. So we're kind of getting to the end of our half-hour allotment. Anybody else got a question? No? Okay.
Willie, I think it would be good to do that virtual tour.
Yep.
So really get a feel for the shop atmosphere when you're in there.
Sure.
you know, so we'll get that set up so they can have a look.
What I will tell you folks too, if you're interested in seeing something sooner than later, and all of you, if you have access to the Future Forward portal, in the longer description, I did put a link to a YouTube video that is a tour of our shop that I give. And if you don't have access to that Future Forward link, you can just go to YouTube and search Fastenal Manufacturing virtual tour. There's two options. One's given by our vice president, and that is a little more at the technical side of things. You know, he's a little bit higher scope for some of our customers. But there is another one. It's about 8 minutes long or so. I think they're both about 8 minutes long. But there's another one that I give, and it is a little bit you know, more at a student level, aimed towards this crowd, trying to show you what we do and how it works, and then we can do you know, hopefully get you signed up for sponsorship or something like that if you're interested. So definitely reach out to me. Your instructors could get my information if you're interested in reaching out and learning about our sponsorship program, or like I said, a one-on-one tour or a tour with you and your folks. I'd be happy to get you in here whenever it works for you.
All right, thank you, Willie.
All right. Thanks, guys.